described in this presentation. So we are going full stack event sourcing, front-end and back-end. And of course, our stack is Azure Cloud, is based on Azure Cloud. This presentation is also built on top of Azure Cloud with Azure technologies and so on. So don't take everything for granted. I have also provided some the other technologies that might be used for this event sourcing. I am also the co-founder of Nedora Technologies, a software consultancy company, which is run by me and one of my best friends at the moment. So we are also helping companies to build enterprise solutions for their best digital world. As mentioned by Irina, I've been working with events distributed systems and event source architectures for quite a while, actually. In this session, we're going to explore like an end-to-end full stack approach to event sourcing using a use case as well, but that for a next slide as well. But I will use that as a concrete example. What I want you to watch for is that this is not just about how we store the data and maybe another way to build systems. This pattern actually spans the entire stack from the user experience as well, front end, back end, and also some parts of the infrastructure. It's not an entire infrastructure, but part of it, more exactly the data store. By the end of this talk, I really hope that you should have a clear mental model for how to design, implement, and scale an event source system across the stack from the first, for example, whiteboard sketch or a Miro board, all the way to the production level code. But let's dive a bit into the agenda, because I think we're going to sit here for roughly 1 hour or so. We'll start with a short introduction and the case study. For this case study, I have chosen a booking reservation because it goes across everything, and we'll walk through the event modeling, what it is, how we can map it, and so on, and see how it flows naturally into event sourcing. From there, we'll cover event sourcing, basic streams, event stores, and snapshots. We'll talk about the pros and cons as well of event sourcing and when it's actually a good idea versus when it's or becomes an overkill. After that, we'll dig into some backend code examples. Then move into some front-end side code examples where we'll compare two different communication options between the front-end and the backend. Finally, we'll tackle a bit the Azure storage and the Azure search index and how are those fitted into the architecture, and we'll finish with maybe a Q&A session. So after maybe 1 hour, we'll leave room to have some questions, and if some questions arise while we are on this call, maybe please let them in the chat so we can tackle them later. Okay, I also want to have some learning objectives. So by the end of this talk, I want you to be able to do a few key things. First, I would like you to be able to explain what event modeling is, how it guides event sourcing designs, and so on. Just in mind, not to explain to me, but to keep them as notes for maybe your future projects and so on. In the second part, I'd like you to understand how to implement event sourcing in both the backend and also the front end, not just in theory, but maybe a bit of code and maybe how an aggregate route looks like and so on. You'll be able to compare two concrete ways for the front end and backend to communicate in an event source system, and also understand the trade-offs. You'll also see how I fitted the Azure table storage and also the Azure search index into event source architecture to store my event streams and also build my projections. Finally, maybe you'll see how taking a full stack event sourcing approach can actually improve the scalability and the user experience in your application. The goal here is actually understanding and not memorization. The two communication options, I'm going to put some lights on it. because we'll discuss exactly the types of decisions teams face on actually real projects when choosing between those two options. Even if you adapt the event sourcing or not, the habit of thinking in terms of events and timelines is still incredibly valuable from my point of view. Okay, we were talking about the case study that I have picked for this presentation, which represents the booking presentation. And to keep the things concrete, we'll frame everything about a booking reservation system. In this system, user can make room reservation, cancel reservations, process payments, and view reservation details. It's simple enough that we can all understand and quickly, but also rich enough to bring out interesting problems like availability, cancellations, and also payments. As we go through the examples, I'd really encourage you to actually map this to your own world. So maybe it's orders, subscriptions, patients, records, appointments, and so on. Whatever your domain actually is, where you are right now with your work. Every diagram and code snippet, you'll see it's really anchored to only this booking scenario. So we have like a consistent thread to follow from start to finish. So we can directly start with the event modeling. And what is it about? Let's start with this. Event modeling, it's a visual technique for describing systems as a series of events over time. This was brought into the development world in, I think it was 2019 by Adam Dimitruk. And it's very used, at least in our company. We rely on it because we need to describe very clearly how the system will behave and how the flow will look like. Then it uses timelines, it uses commands, events, and read models, and it's explicitly designed to align business and technical views, like I mentioned. It's something that you can build while building on the wall with sticky notes and so on, but you can also use tools like Miro that you will see in a few slides. And you can have in the same room both the developers and also the business stakeholders to understand it. This compared to a traditional architecture diagram, which often is going to hide the behavior. Event modeling forces us to think about what actually happens in the system and not how the system looks like. It naturally forces team toward an event first view of the domain, regardless of whatever you ultimately implement event sourcing underneath. We have introduced a limited number of events because we can't go that broad. So let's see some key events in the booking flow. So we have the reservation requested, which is what happens when a user asks to book a room. Then room allocated when the system picks a specific room in order to be used for that reservation. Reservation confirmed when the reservation is officially confirmed. Payment processed when payment succeeds, and reservation canceled when the user or the system cancels the reservation. Think of each of these as a small story. Someone clicks book, the system finds a room, confirms it, processes the payment, or cancel if needs. The important thing is events are actually facts. Those describe something that has already happened, not something we hope it will happen. Some of these events are driven by users and others by some automated processes. In here, I have one example, which is the payment. That payment system can also affect the flow of your app. These events actually become the primary data for that system and stores them at the source as the source of truth in an event source project. This is how a event modeling diagram looks like. As you can see from top to bottom, it's actually splitted in swim lanes. This is how are those called. In the first row, we have the persona. In our case, I have used John. John is the person that wants to book a room in our hotel, and so on. The persona completes a form and makes a reservation. The blue cards represents the commands, so it's actually the input data from the actual user. Those commands generate events, and those events trigger maybe other actions and also help us build a state or a read model. As we can see on those swim lanes that are on the bottom, those are the systems that we interact with in order to achieve this flow. What is really nice about event modeling is that you have everything in front of you. So you can see that after a reservation has been requested, you get the reservation details, and we try to allocate a room. If the room was allocated, we proceed with a payment, with requesting the payment. The user gets redirected to the checkout page, pays, and if the payment is done, then payment is processed. And of course, at a later point in time, maybe the user or the system wants to cancel the reservation, you have the reservation canceled. Each column in the diagram actually represents the timeline, which from my point of view and my team's point of view makes it much easier to reason about the behavior over time. What happens first, what happens next, and how the state actually evolves in our system. Think of this diagram as the blueprint. In a moment, maybe we'll translate the events to something to actually code, and maybe that will become more clear to your vision. But also, what I forgot to mention is that event modeling takes time to build, and also effort, and maybe a bit of a mindset at some point. But maybe people are going to ask, why should we put this effort in event modeling? First, it gives you a visualization of end-to-end flows. You can see the entire timeline laid out. Missing steps and edge cases have a way of revealing themselves. It creates a shared language between the business and the development. So business stakeholders can look at the diagram, follow the story, and challenge or refine before any code is written. It forces an event-focused design. So instead of just asking what's the current state, you can start asking what happened to get here. So what was the cause? And finally, those diagrams act also like a living documentation, at least from a developer point of view. Teams will often keep them up to date. So as the system evolves, which is far more helpful than an out-of-date architecture diagram. And once you start thinking in terms of events and timelines, really event sourcing is going to come very naturally into this. But regardless, if you're going to use the event sourcing or not, then the event modeling can be applied on all the designs, all the design systems that you want to build. So how do we use event modeling in event sourcing? We have defined the events in our previous slides. So there's a straightforward mapping in here. Commands usually are transferred to become a command and command handler in the code. And the events become entries in an event store. The state we actually care about becomes the aggregate root, and the read models in the diagram becomes projection or views that the system maintains. Now, you can think of this as the translation layer between the workshop whiteboard and your actual code base, or Miro in this case, and your code base. Command handlers enforce business rules and also emit events. Aggregates are built by replying events for a given stream and represents the current state implied by that timeline. Read models are projections that consume all the events that are provided by the event stream and provide like query optimized views for the UI or maybe for other consumers, because in here can be also can be systems as well, not only UIs. But let's make that mapping a little bit more concrete to our example. So let's take the make reservation command. In the code, that might be handled by a reservation command handler .handle method. When the handler runs, it validates the business rules, and if everything is okay, emits a reservation requested event, which gets stored in the event store and is going to be part of the event stream of that stream ID. The reservation aggregate is rebuilt by replaying all the events for that reservation for that stream ID, and each event is applied in order to reconstruct the current state. This pattern will repeat over and over again across other commands and events. We handle a command, we validate rules, emit events, and update the aggregate through those events. The important point is that the modeling phase drives these names and flows. We're not inventing them from our mind or database tables from everywhere else. Every business relevant fact, action, rule, call it as you want, really becomes an event that we persist. In here, I have provided for the example of events. I actually made a typo in here for the title. It's not really an event stream example. It's represents some event examples. From the left, we have the reservation requested one, then the room allocated, and each event has different data, and each event is going to be stored into a event stream in our database. More on the contract that I have used in here a little bit later, because I think that's also something interesting. Event store, because we were talking about event stream and storing the events and so on. Let's talk about the store itself. An event store, it's an append-only log, so we never update or delete or do any other manipulation to an event. If an event was committed to our event store, it remains there for good. It's not going to be touched at any point in time. Events are written once and never updated or deleted. They're ordered by time, and to be more specific in here, you can also add a version. So you can do an ordering by the time and specifically by version within each stream. Because of this append-only nature, we can replay events to any point in time, which is a very good thing when debugging, for example, but this comes with a cost, which we will find out later on. If we want to know what the state looked like last week, we can replay up to that point. Also, the append-only model also helps with performance and reliability. Writes are simple, and ordering comes natural, because when you put every event into your store, you're going to maybe add a time on it. Also, the version so you increment everything. You don't let your database to do that for you. And as a side effect, we get an audit trail in our project. For example, we use a lot of audit trails, so this came as a very good benefit for our project. So audit trail that is very hard to achieve actually with standard solutions like a CRUD based designs. To keep things actually more efficient, because we are going to have a huge amount of events in our event stream, we can make use of snapshots. This is to keep things efficient, especially for long-lived aggregates. So snapshots are just a performance optimization. Don't consider them as a source of truth. Your source of truth will always be your event stream. This pattern is only used to decrease the number of calls that you do to your database or to the data that you query from your database. It's a common pattern is to take a snapshot at every n events, for example, 50 events. We store the snapshot along with the version number. When we need to rebuild the aggregate, we load first the snapshot, which captures the state as a version 50, for example, and then we replay the events from 51 onwards. That way, we don't have to replay the entire state from the beginning every time. And snapshot frequently is a tuning parameter. Let's say it's a nice addition to your system. You can adjust it based on how big your aggregate and how fast you need to load them. And because events are your source of truth, you can always regenerate snapshots if needed. We actually, like a side note, we actually do something similar, but not with our snapshots, but with part of a projection. We have a re-indexing strategy where if we need to upgrade our index, and Azure index is immutable, so you have to do another index in order to get a new contract in there. We read the event stream and we rebuild our index contract with all the records that need to be in there. We put another version into it, and then we use that version on the website. This is actually how an event stream really looks like. It's a concrete event stream for a single reservation. You can use any type of reservation ID in here. I have used a GUID and or unique identifier, and it's quite hard to read it. But you will see from left to right, so from here to right, that event 1 is the reservation requested at, let's say, hour 10. The event 2 is room allocated at 10:01. The reservation is confirmed at 10:02, and the payment was processed as at 10:05. This sequence of the events is actually the timeline for that specific reservation. By actually reading this stream in order, we can reconstruct the entire history and the current status of that reservation. This also gives us a precise audit trail. If someone asks what happened with this reservation in here, for example, or you literally have to have a story to record every event by event if you don't have something like this. Typically, each aggregate type, reservations, rooms, users, and so on, will have its own stream, each telling its own story in the end. Everything comes with pros and cons. Event sourcing comes with a number of compelling benefits, but also with some constraints altogether with it. You get a complete audit trail for free, actually. As a side note, you can also use this for your BI, for example, if you need to keep track of each event, when and what happened at a given time in your system. It's very useful. Every change is captured as an event, which is a big deal for compliance-heavy domains. You get this time travel. You get it not as a built-in capability, but you quite have to build like a tool in order to go through it. You can look at the system as it was at any point in the past, which is great for debugging and analysis. Again, with an asterisk, you have to build a tool for that as well. Event sourcing also supports scalability. Append-only writes and CQRS separating reads and writes can help you scale out under heavy load. Events themselves are meaningful to the business because they encode business facts. They can be reused for analytics, like I said, for the BI, reporting, and even machine learning. And those really act as a stable integration contract in a distributed system, which makes decoupling very easy. Of course, many of these benefits are most valuable in domains where history and behavior truly matters. As cons in here, it's not everything like Go event sourcing, because it definitely has its trade-offs. First, it adds a lot of complexity. Both the implementation and also the mental model are more involved than in a simple CRUD system. You're also dealing with eventual consistency. Keep that in mind also for the front end. Some read models will lag behind writes, and your UIs and the business processes need to be designed with that in mind. Storage grows over time because the events are never deleted because of that append only. So you really need a strategy not only for snapshots, but maybe consider also archiving or even stream compaction. And debugging will be very different. So instead of querying like a single table for a current state or a read model and so on, you might be replaying an entire event stream, which might take time and also requires tooling. We have built a ton of console apps in order to achieve our debugging and get to our needed scenario, for example. So it is actually a powerful tool, but it's not really for free. And when I'm saying for free, is not immediately said in money. It's also about the time that you spend to build those tools, maybe, and actually logging. I think from time to time can be misleading here and there. Should you use event sourcing? Depends. I put it like it's suitable and not suitable. It's very compelling in domains with strong audit requirements, for example, finance, healthcare, or legal. And also other regulated industries, for example, like public systems and so on. I know those use a lot of audit requirements as well. And actually, I would consider a question in here. If you have the question, who did what, when, and why, then you should consider event sourcing. Why not? It's also a good fit for complex businesses and logic in that business, where understanding the sequence of decision matters as much as the final result. We have that into our system, and that was the main point on why we choose to use event sourcing. Systems that already use CQRS or event-driven architecture often find event sourcing to be a natural extension. It's particularly strong for temporal queries, questions like what was the state at that time, or how did this value evolve over time. It actually is going to help you to come with a straightforward answer. What I don't consider it's very suitable for simple CRUD applications, basic admin screens or configuration pages, or I don't know, small internal tools. Event sourcing is going to become a very hard to maintain and follow. So if your system is purely about high write volume logging, but you need to reconstruct state from those logs, a simpler logging approach might be sufficient. If your team, and this is very, very important, if your team has a limited experience with these patterns, and I'm not talking here about the event sourcing or any other things related to this presentation, but for example, event-driven architectures, don't do it. It's going to be very hard to get them up to speed, and definitely don't do it if you are on tight deadlines. And if your only requirement is give me the current state with no need for history or time-based analysis, a straightforward CRUD model is often the better choice. The key here is actually to stay pragmatic. Use event sourcing where it evolves, where it solves real problems, and don't use it just because you want to use it because maybe it's a latest technology or it's something in trending and so on. It might cause you some headaches in the future. This is something that I have considered personally, so it's not written in stone. So to make like a more concrete decision, we can maybe use this decision matrix. Think of it as a table that maps requirements like strong audit trails, complex business rules, simple CRUD, or temporal queries. To a recommendation, use event sourcing, don't use it, or it depends. As you walk through the metrics, row by row, some cases are clearly a yes, like audit-heavy systems, like we discussed previously. Some are a clear no, where you can rely on CRUD operations, and other are really negotiated based on the trade-offs. It's not a strict rule book, but it's a maybe good starting point for a decision. So I think we can continue with some coding examples. Let's focus first on the backend code, starting with the reservation aggregate. So this aggregate actually captures the core business rules around the reservations. It has some fields like reservation ID, room ID, user ID, status, blah, 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 and so on. And for each event, we have an apply method. And this is actually how the event, how the aggregate route is going to be built. It is going to have a lot of apply methods. We have an apply method for apply reservation requested, initiates as the reservation, apply reservation confirmed, which is going to update the status. Then we have the payment processed, which is going to mark the reservation as paid or not, and the reservation canceled, which is going to mark our status as canceled. The important idea is that these apply methods are the only place where events modify the aggregate's internal state. That really makes the behavior explicit and also testable. This is another key point for aggregates. Those can be unit testable very easily, and it's going to provide fast feedback for that. As a point, we run our aggregate test in under 10 seconds. I don't know how many we have, but we have like a 10 seconds threshold. These same methods are used both during replay and during normal request handling. So you have actually one consistent definition for what the event does. This aggregate route is going to be used for maybe rebuilding a snapshot, rebuilding the projection, and so on. So you can make use of everything that the aggregate route has internally. If anyone, for example, asks what does reservation cancel mean in the system, there's exactly one method to look at. Next, let's look at the handler itself. In here, we have the reservation command handler. When a command like make reservation command comes in the handler, first loads all the events for that stream and rebuilds the entire aggregate. Then it validates the business rules, for example, making sure that a reservation doesn't already exist, or the dates are valid, or the end date is not before the start date, and so on. If the command is valid, it creates new events and appends them to the event store. We also use an optimistic concurrency check based on the expected version of the stream. Also, that prevents conflicting writes when multiple requests try to change the same reservation at the same time. Each command handler is focused on a specific use case, which helps the code compact and easy to reason about. And importantly, this keeps the domain logic out of the controllers and infrastructure, helping to maintain a bit more of a clean architecture. But now we go to the, I'd say, a more interesting part, bringing the event sourcing to frontend all together. And in here, I have some reasons why, and why we also included event sourcing in the UI as well. First, it enables offline support. The front end can make use of local databases in order to store the event streams. In here, I'm going to discuss about the IndexedDB. I hope all of you know about the IndexedDB. IndexedDB is a client database that is supported for 95% of the browsers already, and it's a key value per database. So users actually can keep working even when the network is flaky or offline, because we use only the client database. We don't send actually requests to the backend. It enables optimistic updates. The UI can actually respond instantly by applying the events locally, making the application feel fast, but the backend catches up asynchronously. It's a very important strategy that you have to apply with the communication between the backend and the front end to not skip a lot of events, maybe. But this is something that each business case decides on its own. You get automatically the front end audit trail. We also use this in our applications right now, because we need to see or to inform what the user has interacted with and what were the actions at a given point in time if they have faced like an error or something. You can see exactly what the user did in what order, which is very helpful for debugging and understanding the user behavior. And finally, you get the same reconstruction strategy as in the backend with the time travel benefits and the UI layer that you have on the backend. So we have used two communication options in our systems. So the first communication option is to send the entire event stream from the front end to the backend. I know it sounds crazy. We have also hit the limit at some point in time when we sent a lot of events in the event stream and we had to rethink our strategy. So in this option, IndexedDB is actually storing the entire event stream on the user's user's database on his local device, on her local device. When we're ready to sync, the front end loads all the events for a given reservation, for example, and sends an object like a stream ID and also the events to the backend. So we have like the reservation ID. Then the backend replaces the event stream and stores the events in its own event store. You can think of this as actually sending a full movie, or send the full movie of what happened on the client. The backend gets a full context and can validate each event in sequence. This provides a very strong end-to-end auditability, and the backend sees the entire interaction history, which is valuable in domains like fraud detection or complex workflows, where the path matters as much as the outcome. On the other hand, we can send the aggregate to the backend as a command. It's exactly the example that I have presented with the make reservation command. In this approach, the front end still stores the events locally and replace them into a reservation aggregate on the client. But instead of sending all those events, it sends a make reservation command, and that represents the desired end state. The backend then uses its own historical events and rules to generate new events from that command. You can also think of this as sending the frame of the movie rather than the whole film with the first option. It's actually leaner because this is a good fit when you care more about the final state and performance than about every detail of the user's journey. We have discussed in the previous slides about a contract. Since January, we are using one type of contract, and that is called cloud event. It's actually a specification, the cloud event specification, that includes fields like spec version, type, source ID, time, data content type, and so on, and you can extend those things. And what we care about most is the data. So cloud events give us a standard way to wrap event payloads with metadata, what type of event is, where it came from, when it happened, and how to interpret the data. We have adopted this cloud event to reduce custom boilerplate and make it easier to integrate with also other services and platforms, because many modern tools and platforms already support natively cloud events, which is actually useful for future integrations. I hope I'm not wrong, but I also know that Stripe uses the same contract as well for their events. I'm not 100% sure, but in our example, both and also our project, both front end and back end are using cloud event structure to keep everything aligned. In many cases, the front-end events from the event stream are going to be mapped to another event on the domain event, and that's usually a one-to-one relation. So, for example, a front-end reservation requested is mapped to a reservation requested. Then a user room selected might map to a backend room allocated. Payment initiated on the client can map to a payment processed on the server. Not really going to happen, but like just for the sake of the example. And this actually makes it easier to reason about behavior across the stack. Also, from our experience, it also reduces the miscommunication between front-end and back-end teams. We usually work full stack, but we also saw the benefit because once you have implemented the event in the front end, it's very easy to apply it on the back end. You already know about it, or vice versa. By default, I'd say to aim for consistent naming, and you occasionally you might deliberate naming differences for clarity, but the baseline should be aligned. Let's maybe compare a bit the options that I have presented previously. So actually the sending the event stream versus the aggregate route. Let's focus a bit on the event stream. This tends to have like a larger payload, and it uses a lot of network, but it gives you a rich audit trail and better insights to how user has behaved on the website. Keep in mind that it's very easy to hit the limitation because of the event stream size. It can also make debugging easier because you can replay exactly what happened on the client. On the other hand, sending the aggregate command is leaner. It uses a smaller payload. Potentially, this is not going to impact the network bandwidth that much and can be simpler for the backend to process as well. But it sacrifices some of that detailed history that we were discussing previously. So when we look in this comparison, maybe keep in mind the payload size, maybe the audit trail, maybe the network usage, and so on, backend validation. So you can summarize it as maybe the option one if you need like more data, more insights, more audit. But if you want maybe something simpler, leaner, you can use the aggregate route. Maybe a practical guideline is to choose option one when detailed history really matters, and option two when performance and simplicity are the top priorities for your application. And you maybe don't have to pick only one. You can maybe mix the both of those worlds into your system. Why not? Okay, in here we have a small front-end code in how we have implemented, or how I implemented the wrapper over the IndexedDB. So let's look a bit of the on the front-end code. We treat the IndexedDB as a small event store on the client. Like I said previously, there's a initiate function to open the database and create the store if needed. And then also the append event to store each new event. And in order to retrieve a stream ID or a reservation, we have the get events to load the events for a particular reservation. The rest of the front end doesn't need to know anything about IndexedDB because you can use it as an interface, and then you can easily swap because you have everything abstracted. You can swap and maybe change the storage if you really want to. It also this is what makes the offline support possible, because you store everything locally, and the front end is going to rely on your IndexedDB event stream. On top of that event stream, we have an implementation for the option one. This is called the event stream sender. This is getting all the entire event stream from the IndexedDB. It's going to put it into a key value pair, the stream ID and the event stream, and it's going to send it to the backend. Again, it's very easy to hit the limitation when sending an event stream. For the option two, we have an aggregate sender. This loads the same events, replace them into a reservation aggregate, which can be seen in here. So we do an apply, and from that aggregate, we do the to command in order to build the command, and we send the make reservation command that represents the current state. Both options rely on the same underlying front-end event store. So nothing has changed. The event stream is still there in the IndexedDB. The capability of offline support is still there. The only difference is how you send the data to the backend. So it's actually purely the shape of that payload that is being sent. This actually those options gives us actually a lot of flexibility. Well, we can start maybe with one approach and maybe evolve with another approach together with the requirements change, or even support them for different use cases. Like I said, we need to store the event streams and also the projections. This is based only on Azure at the moment. Is the tech stack that we use. So I have made my examples to suit the Azure. Why we choose actually table storage is cheap. Azure table storage is really cost effective and really highly scalable. And we also have one question every time when we choose to go with a store. It's how do we want to query our data? In this case, we have a partition key and a row key, and the data is very easily accessible. It's a very good fit for append-only event streams, where you mostly write new events and read them back by a key or maybe by an event stream. Their API is really simple, which actually is going to lower the barrier to adopt this technology. And if you're already in the Azure ecosystem, it integrates very nicely with other services. For many event source systems, we have used only table storage, and I think we have only one or two where we used Cosmos DB. But table storage is really a pragmatic choice for storing those streams without needing a specialized event store right away. Definitely, it comes with some limitations. One of them was hit pretty soon in our process, and it's very important to have it in mind. It doesn't support complex queries, and you're largely limited by the to a partition key and the row key lookups for some basic filtering as well. In our case, we have built like I would say hacky thing to query all the records that are having the same primary key, but the row key has like a version stamped into it. So we have like a .1, .2, .3, and we have to query all the entire stream. So it's also eventually consistent in some scenarios, which means that new events might take a short time to appear in your queries. And this is something that we have hit quite soon in our process. There's a 1 megabyte limit per entity, which means that you have to keep your event or snapshot reasonably small. And there's also no cross-partition transactions, which influences how you design your aggregates and stream partitioning. But with these limitations, you are quite forced to create projections. So you use actually the table storage to append only the event streams, and then you build a specialized read model in other stores for complex queries. And this is how we ended up in search in using Azure Search Index, because it's built for fast and full text search and rich querying. It's particularly good for projections and read models that needs flexible query capabilities. It might look a little bit overwhelming with the filter type that you have to write in, but it's going to be very useful in the moment you tackle them. The UI might need to search reservation by username, for example, date ranges, statuses, or combination of those. You can achieve easily these things with Azure Search Index. And also It supports faceting and more features that are hard to replicate with table storage alone, actually. But in CQRS terms, the Azure Search is a great candidate for a read-optimized model, while the event store remains in your write model. So I have again created like a decision matrix. It's not really a decision matrix; those are like alternatives that you might use. I'm going to be honest, I have used only one from this, which is Martin, for as a specialized store. Other than that, everything I have built was on Azure. But a system with a very strong transactional requirements, for example, versus one that prioritizes cheap, scalable storage, you can actually try to identify maybe another way or option to store your data for the projection. Like I said, this metrics is more of a conversation tool, not really a strict rule. And really, for us, it didn't make any change. We have always been stuck with Azure, stuck in a good way. But let's see how scaling can happen using event sourcing. It's actually giving us a lot of leveraging for scaling. Because each stream is independent, we can partition data by the stream ID. This makes it easy to distribute load across partitions and nodes. We also avoid cross-partition transactions by design because each aggregate generally lives within a single stream and partition. That's really a big advantage when scaling in cloud environments where cross-partition operations are expensive or limited. And the model supports near linear scalability as you add more partitions and capacity. It fits nicely with services like Azure Table Storage, Cosmos DB, and maybe other similar systems. You can also use different app services, going from serverless to container apps and so on. So you can basically do everything that you want to do with event sourcing as well. But let's see how scaling with event sourcing actually works on the front end and maybe on the back end. From my point of view, in the front end, it makes a lot more sense than in the back end. Because in the front end, the event sourcing and related patterns also help with the one of the best capabilities, offline first, because it means that the users aren't blocked by network latency or outages. They can keep working on your app, and the application will sync back when it gets back online. You can have like a service worker for that to help you sync your services. It has optimistic updates, and this comes with making making the UI looking like very fast. And users can see immediate feedback from your app, which is actually seen like a very good running application. This patterns are actually valuable on mobile devices rather than making use of them in the web application first. And in low connectivity environments, but it actually improves the user experience almost everywhere. On the backend, event sourcing fits naturally with scalable architecture, but mostly with CQRS. Writes go on the event store, reads go in the projection. Each read model on Azure Search Index can be scaled independently based on its own load and any performance requirements that you might have. And if you, for example, need a new read model later on in your system, you can make use of event buses, in our case Azure Service Bus, because with each event that gets stored into your event stream is going to be published and is going to be cached by other subscribers. So you can have different subscribers building their own projection based on your data that it's published through all the events. And this approach really works well with the microservices and event-driven systems that many teams are already building in our world. So some key takeaways that I would say, event modeling is a very powerful way to design event source systems, and it gives you a visual shared understanding on your domain. In here, I will come with an asterisk because I think this works very good hand in hand with event modeling. That's, from my point of view, the start point of understanding your system before building the actual systems. It gives you a strong audit trail and enables scaling. You've seen actually two concrete backend communication options from the sending the event stream and also the command with the aggregate already built, each with its own trade-offs. And finally, the Azure services like table storage and search index, which actually makes it practical to implement event stores and projection in a scalable way. My recommendation would be to not try only event sourcing on, let's say, small projects, because it's very easy to get excited about it and really wanting to implement it. Now, I would put event modeling in a real domain problem, not just like a toy or an example, but get the right people in the room and put the start with the events and put everything into an event modeling option. Then from that point on, I think the choosing the technologies and everything that you need to build out your systems are going to be much easier. Also, if you want to use event sourcing into your system, implement an event store with snapshots from the beginning, with no doubt. It's going to help you a lot along the way. And also invest time in tooling. Like I said, we have built a lot of console apps in order to replay some event streams, in order to debug what happened at that point in time. That's actually something that really makes a difference between a prototype and a system that you can actually run in production. That's something that I can also give you. I'd like to thank you for your participation in here and for taking your time to listen to me. I really appreciate that you have to stay this maybe late for some people, and definitely if I can answer your questions, I'll be more than happy to answer them. So maybe let's have a small discussion about this.
So there's a question from YouTube, the last one.
Are you going to read it, or
yes, I can read it. So is there an issue if for some reason the user loses his or her data stored in the IndexedDB?
Yes. If that was not synced to your backend, definitely yes, is going to be a problem. It's something that we know we face, but we are keeping it like, okay, it is what it is. We lose that. So the user will actually have to redo their parking booking at some point in time. That's unfortunate.
I have a follow-up question on that. So how do you handle those scenarios?
You don't handle them.
You don't handle them. Okay.
No, you let them. We think of them like, okay, the user browser has crashed. It is what it is. It's something that we can't really control. We don't really have the capability to control what happens on the client side. We provide, let's say, the capability of having the offline support, but we also think of it as in a very optimistic way. So if something bad happens on the client side, I know it doesn't sound right or good. It is what it is in the end. It's something that we can't control.
Okay. And there is another question from YouTube from the same guy. What
Yes.
materials, books, courses would you recommend most for learning event sourcing, especially at a more advanced level?
I think on the event modeling website of Adam Dimitruk's, there's a book that is very popular in there. I can share the link maybe with you, and you can share it in the
Yeah, that's
community.
fine.
I have it right now prepared. What else? A lot of YouTube, actually. I know it sounds funny, but a lot of YouTube. It has a lot of good material things um, from domain-driven design, clean architecture, and so on. And the one guy that comes into my mind right now, I think is how is it called? Nick Chapsas. He's a Greek person. He's
Yep.
very, very smart, very nice presentations he has there. And I think Milan Jovanovic or something like that. Hopefully I didn't.
Can I chime in? It's like Dome Train, Nick Chapsa's learning platform also have some event sourcing courses. I don't know exactly what authors made what, but for sure there are a few over there.
And if you also want some event sourcing, let's say topic posts, you can go on LinkedIn and follow Yves Huleven. He's one of the architects that I'm working with, and he's very passionate about this topic as well.
Okay, we're gonna take one more question from YouTube, and then we're gonna stop the stream and let you all unmute yourself. So, last question for a new project: how do you exactly decide when to use event sourcing and when not to use it? You mentioned it. It's when you have to know when, who did what, but you can achieve this without event sourcing as well.
Yeah, definitely you can. Like I said, in our domain, being a smart parking retails, we always need some information at given point in time. And for us, we found that this is actually the best option for us. Definitely, it comes with the mindset that you have to change. And we also have a lot of audit trails and also some BI integrations as well. So we do a lot of reporting, and we have experienced BI reporting also with CRUD-based systems and also with event sourcing systems. And I can tell you that doing this in an event sourced manner helped us a lot, because we didn't have to build, for example, adapters or anything else on top of our CRUD operations to retrieve the data to send them to BI. BI is automatically listening to our events, and they catch the data that they need from our events.
Cool. Thank you all for being here. We're going to stop the stream and we're going to be on Zoom.